Welcome to The Explainer. Today, we're diving deep into what it really takes to get a renewable energy project off the ground. You know, how you go from that big dream of clean power for your home or business all the way to the hard data that makes it a reality.
I mean, it's a powerful idea, right? The dream of energy independence, of powering your own world with clean energy. But, and this is a big but, a lot of people discover there's this huge gap between that amazing dream and a system that actually works. And that gap, it can feel, well, pretty complex.
Okay, so let's get right into it. The secret here, the real secret, isn't just about buying the fanciest panels or the biggest batteries. Nope. The magic happens way before any of that. It's all about having a solid plan, a blueprint. Because without one, you're basically just guessing, and that can be a really, really expensive guess.
And that whole blueprinting process, that's step one, designing the system. Just think about it. You'd never let a builder start on a house without a detailed plan from an architect, right? It's the exact same idea here. This is where you map out your entire energy future before you spend a dime on equipment. So this whole design phase really boils down to two key things. First, you got to figure out your capacity. You look at your roof, your location, the sun you get, and you ask, how much power can I realistically generate? Then second, you have to size your battery. How much of that power do you actually need to store for later, for when the sun goes down? And this is where it gets really interesting, because the reason you want a battery completely changes how you design the system. Is its job just energy shifting? Storing that daytime solar power to use at night and cut down on your bill? Or is it for backup? Is it your safety net for when the grid goes down? The answer to that question changes everything about the size and type of battery you're going to need. Okay, so you've got your blueprint. Awesome. But what's next? I mean, you have this great design on paper, but how do you know it's actually going to work in the real world? And maybe even more important, how do you know it's going to be a good financial investment? And that right there is the key question. It's what separates a cool idea from a genuinely great project. You have to know if it's going to deliver. You can't just cross your fingers and hope. And the answer? Well, the answer is in simulation. It's about forecasting, about testing your plan against reality before you even think about building it. So to get that answer, the pros run these really detailed analyses, and they're looking at three crucial things. First up is energy yield. That's the big one. How much power will your system actually generate, day in and day out? Second, something called curtailment. This is super important. It's any potential energy you might lose because you can't use it or store it at that moment. And finally, the bottom line, financial performance. What's the return on your investment going to look like over time? And this chart, it perfectly shows the goal of all that forecasting work. You want to completely get rid of any expensive surprises down the line. A successful plan, a really good one, is when what you predicted on your spreadsheet almost perfectly matches the actual performance you get once the system is up and running. So, as you can probably guess, you're not doing this kind of complex planning with a calculator and a notepad. To turn that blueprint, that forecast, into a real-world, high-performing system, you need the right set of tools. And a lot of the time, you need some expert help, too. Yep. To handle all these tricky calculations, developers and engineers have a pretty specific toolbox of software and services they rely on. Let's take a look inside. So this table gives you a little peek inside that pro toolbox. You can see there's specialized software. A lot of it is actually Excel-based that does everything from calculating your total PV capacity to correctly sizing really crucial components like your inverters. And that's essential, because every single part of the system affects every other part. And then, when the numbers get super complex, that's where expert consulting comes in. It's that human sanity check that makes all the difference. Now, all of this super detailed planning, it's not just about getting today's project right. It's actually paving the way for a pretty incredible future. A future where our home energy systems are way more than just panels and batteries. They're going to be intelligent, they're going to be integrated, and totally automated. And the next big leap forward here is something called a smart electro system. The best way to think about it is like a central brain for your home's entire energy world.
It's a system that's constantly making decisions on its own to optimize absolutely everything.
And just look at the scope of what these systems are going to manage. I mean, this is incredible. It's not just your solar and batteries anymore. We're talking about one single smart system that's coordinating your EV charger, your boiler, even your gas supply, all while automatically managing your energy bills and tariffs to constantly find the cheapest possible option. Now that is true optimization. You see, it's that level of total integration, that kind of advanced automation, that's what finally takes us beyond just making our own power and into real, actual energy independence. And when you start seeing features like arbitrage being built in, which basically lets your system automatically buy power when it's cheap and sell it back to the grid when it's expensive, it leaves you with a really fascinating final thought. As our homes become these little power plants, are we all about to become energy traders too?